What's going on, everybody? This is Dave from Steel City Jones Flight Academy. Today, we're talking everything about the H20 and H20T cameras. We get potential customers calling us, considering getting the Matrice 300. It's a big expense. They're looking at the H20 and H20T camera. The H20T camera is a big expense. And a lot of people want to know, what can I do exactly with it? Even though we have a very comprehensive review video showing all the features and functionality, a lot of things come down to two different things: resolution and what can we do with it regards to mapping and survey grade work. Let's go ahead and jump right into this. These are all very valid questions. Everybody wants to go ahead and get the maximum amount of bang for their buck for their investment, and they want to really kind of know what can this do and what are the limitations. So, from a resolution standpoint, let's talk about and compare this to the P1 camera. Again, we have multiple cameras inside here. Let's just throw away the thermal camera side of things because that's really not applicable to any of these type of topics of discussion. We have a wide camera on here. It's a 12 megapixel camera. Then we also have a zoom camera in here, which is a 20 megapixel camera. So a lot of people obviously want to gravitate automatically to the camera with the high resolution, which is the zoom camera. So we're looking at it from really two different perspectives. One of them being a mapping application and or survey grade work. The second being in more types of resolution for project progress, building inspections, and architectural photography. They want to photograph buildings and bridges and different types of architecture and want higher resolution. So we're looking at it from that standpoint. So we're going to break that down into both ways here. So first, before we get into the survey grade and mapping application, let's break down the resolution differences between what I would consider the three cameras are: wide, zoom, and P1. So I did a test where we had the drone directly over our landing pad. And I wanted to go ahead and find out exactly what distances gave us the same overall framing and ground sample distance. So we came to find out that the zoom camera can't go 1-to-1. The minimum we can go is 2-to-1. So we took that from the highest flight altitude that we could, which was 400 feet. Then we figured out what type of distance we had to go for the other two cameras to get the same ground sample distance in framing. So with the P1, that came into 325 feet. And then for us to go ahead with the wide camera, we had to fly that down at 200 feet, which makes sense because the zoom camera is 2-to-1. So we then took those three and compared all three, and that's what you're seeing on your screen right now. And as you again, no surprise to the P1 camera, you're getting more resolution, more clarity. You can see the details in the concrete. And again, while this is very zoomed in, you are seeing the differences between the three. Again, it's not surprising that the zoom camera has more resolution than the wide camera overall, but that's how they all fall as relationship to that. So when you're looking at overall resolution, and you can see where we start out with those three when they're not zoomed in at all, they all look good when it's not zoomed in. But again, I'm trying to help you determine at what level of clarity do you need for these things to be able to get that out. You'll see now, let's go ahead and not zoom quite as far into details. Let's go ahead and go and have them zoomed out just a little bit more. Now you can see what the resolution differences are. That way you know exactly, really from a resolution standpoint and pixel density and quality of pixels, where things stand. So now let's go ahead and really look at it from a mapping and a survey grade type of standard for what a lot of people want to get to. We can map with this camera? Yes, we absolutely can. We can make 3D orthomosaics with this and 3D models with this camera. But can we get centimeter level of accuracy? No. Can we get survey grade accuracy or precision with this camera? The answer is no. So we're going to go ahead and break down why we can't do that and what we can do with all this stuff. Again, now in relationship to this right here is the P1 camera. This is a full frame 48 megapixel camera. And this right here is a mapping sensor. This is designed for mapping applications. We've actually mapped and did mapping projects with the H20T camera. And the orthomosaics, like as you're seeing on your screen, are very, very good. If your deliverables to a client include just a 3D modeling for project progress updates, for example, or doing a 2D map, and we don't have to even do anything where we're going to go into line work or CAD work that's going to give a finalized survey, then this is going to be fine. If we have to go ahead and get within what I would consider to be a tenth of a foot of accuracy, because that is pretty much the standardization for survey grade equipment, then we need to use this. So you might be saying to yourself, why can some cameras with 20 megapixels be good and a camera like this not be good? Well, again, we're looking at it from a standpoint that this is a camera with multiple cameras inside it. And its elements and everything are very complex in here. There's no way for a company like Pix4D to develop a true camera profile for their software. When we're talking about the majority of the accuracy and precision being in the processing of the data, that's the ultimate limiting factor. So again, when we're looking at Pix4D, you see all the parameters that go into a camera profile. Whereas this is a prime lens. This is a full frame sensor. This has a mechanical shutter. This has high quality glass. And again, a prime lens. All perfect things that we can go ahead and provide and make up a very good camera profile. Versus this, we really can't do that. So it's in the processing that it's going to affect the accuracy and precision of the overall output, but we're definitely not going to get anything that's survey grade, which again, survey grade in my definition is going to be a tenth of a foot. You're not going to find any survey grade company, well, I should say, you're going to find very little. Hopefully, I think I'll rephrase this. You're going to have a hard time finding a reputable survey company that's going to go ahead and guarantee their work and certify and stamp a survey project of anything better than a tenth of a foot. Because even when we have to validate our data with our check shots, the Trimble equipment has a certain amount of vertical noise that's going to be on it that is going to be very difficult to get better than a tenth of a foot, even when we're using something like this. But we can give very high quality deliverables as long as we know what those deliverables are going to be. 2D maps, 3D maps, project progress, along those lines are going to be good enough and suitable for this. So you just got to know, what are you trying to achieve with your end product deliverables, and measure that against the things that I'm mentioning before that. So I hope this video helps. If you have any questions, let's start a conversation down below. I'll be glad to talk to you again. Thanks for watching. We'll talk to you soon.